Hello, good people of pre-calculus. We are in the Unit 3 note packet, and we're going to talk a little bit today about spooky quads. All right, this should be your first page right here. All right, so some important information about quadratics that we should be able to do. I want you to graph this. And as we graph it, I want you to give me some information about it. We'll start with the y-intercept. Just a quick reminder that the y-intercept is the point where the function has an x value of 0. So if you plug 0 in here, you'll get that our y-intercept is at 5. I'm going to go ahead and plot that right here. 1, 2, 3, 4, 5. Next thing is finding the x-intercepts. Now, I will admit that this factors very nicely, and you can use that to find the places where the y value is 0. However, we're going to try something a little bit different today because it's going to be useful in the next unit. And that is my boy, the hammer, the tool that always works. That's right. I am talking about the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So you should be able to use this guy. And you should also know that the expression inside the square root has a name. It is called the discriminant. And the discriminant is going to tell us how many x-intercepts we get. If the discriminant is positive, we're going to get 2. If the discriminant is 0, we're going to get 1. Boop. And if the discriminant is negative, we're not going to get any at all. All right, so without further ado, let's use some quadratic formula. The first thing we're going to do is identify the values of a, which is 1, b, which is negative 6, and c, which is 5. All right. Second thing is I want you to begin by plugging those numbers just into the discriminant, which means in this case, we're going to get negative 6 squared minus 4 times 1 times 5, and bippity-boppity-boo, that is a 16. All right, now that 16 is important. That tells us how many x-intercepts we should be getting. 16 is bigger than 0, so we know that we are going to get 2 of them. All right, so now that we know that this is 0 and that this is going to be 2 solutions, next step, x is equal to the opposite of b. Our b value is this, so 6 plus or minus the square root of b squared minus 4ac, which we already found. We already did this, so take that 16, just plug it in here. All over 2 times the a value. So now that simplifies to 6 plus or minus the square root of 16 is 4 in the numerator. The denominator, both of these are being divided by 2. So put a 2 here and a 2 here. And we get that the x values, that the x-intercepts are 3 plus or minus 2, which means x is going to be equal to either 1 or 5. Boom, boom. There's 1, 2, 3, 4. There's 5. All right, so next step. Now that we've got our x-intercepts and our y-intercept, we need to identify the minimum or the maximum. It's not going to have both. What you want to do is think about the graph. In this case, we can see that this one's going to open up, which means that somewhere down here it's going to have a minimum. It will not have a maximum. Go ahead and cross that off. The next thing, we need to find the location of that minimum. We do know because of symmetry, it's going to be on this line halfway between 1 and 5. And so it's going to be at the point where x is equal to 3. And so if we want to know what the y value at that point is, we simply take 3 and we plug it into our equation right here. 3 squared minus 6 times 3 plus 5, which is going to give us negative 4. 1, 2, 3, 4. There's our point. Our minimum is at 3 comma negative 4. Right? Graph's going to look something like this. And so our domain would be all real numbers. We've talked about how for quadratics it's always real numbers. And the range is going to be anything above this y value of negative 4. So your range is going to be from negative 4 included to infinity. All right, roll to the second example. All right, on this one, g of x is equal to 2x squared plus 4x plus 5. No sweat, Mr. Klein. Y-intercept, I know if I plug in 0, the output is going to be 5. Hey, it's just like the last one. So 1, 2, 3, 4, 5, right there. Next thing, we need the x-intercepts. Once again, I'm going to ask you to do this one using the quadratic formula. So a is equal to 2, b is equal to 4, c is equal to 5. Our discriminant is b squared minus 4ac. b is 4, a is 2, c is 5. Oh, now do you see what I see right here? That this is 16. Take away, what is that, 40? So we're going to end up with negative 24. So the discriminant is less than 0. And if the discriminant is less than 0, we are looking at this situation right here, which means there are going to be 0 x-intercepts. So cross this off, no x-ins. All right, but I still want you to be able to draw the graph, which means we still need to be able to find where that axis of symmetry is. You'll recall that on the last problem, we figured out the axis of symmetry was at 3 because it was halfway in between the x-intercepts. Well, we don't have x-intercepts in this case, so we need another method for finding that axis of symmetry. Negative b over 2a to the rescue. All right, so on problem number 1, we used option 1, which is just we found the average of these two x-intercepts. But we don't have to do it that way. We could also find the axis of symmetry because it is always equal to the negative of the b value divided by 2 times the a value. So that's what we're going to do right here. We're going to say that the axis is at x is equal to negative b divided by 2a, which in the case of this problem would be negative 4 divided by 2 times 2, which is negative 1. So our axis is right here. We know that the graph is opening up because we've got that leading coefficient that's positive. So if it's opening up, that means that we're not going to have a max. We are going to have a min. We know that that min will have an x value of negative 1. Now all we need is the y value that goes with it. And just like we did on the last problem, you're going to get that by plugging in negative 1 to the function. So g of negative 1 is 2 times negative 1 squared plus 4 times negative 1 plus 5, which is going to lead us to, let's see, this would be 2 minus 4 plus 5, which is 3. So our minimum is at 3. We know the graph over here goes through 1, 1, 2, 3. We can draw the rest of the graph based on those 2 points that we got. Not my finest parabola. And you'll notice that it doesn't have any x-intercepts. Domain is all real numbers. The range is anything bigger than this y value right here, which was 3. So from 3 to infinity. Cool. Turn to the next page. Number 3. Okay, we start with the y-intercept of h of x. I'm going to throw a 0 in. I throw a 0 in there and there. I get 1. So on over here, I know this thing is going to go through boop, that point right there. Next thing, notice that this is written backwards, right? A is that value, B is here, and this is C. So A is -1, B is 4, C is 1. Discriminant is equal to b squared minus 4ac, which would be 4 squared minus 4 times -1 times 1, which is going to give us 16 plus 4 is 20. That's a positive number. How many x-intercepts do we have? That's right. We have 2 x-intercepts. Let's go get them. Well, we know that the y values will be 0. We're looking for the x values. We're going to take this and we're going to plug into the quadratic formula. So x is equal to the negative of b plus or minus the square root of the discriminant, which is 20, all divided by 2 times the a value. Now, I picked this one out because I want you guys to notice that you can do something with this term right here. Little bit of work off to the side. Zip. Square root of 20 can be simplified by noticing that there's a perfect square that divides into 20, and that's 4. So you'd want to rewrite this as the square root of 4 times the square root of 5, which means that this is really 2, right? Square root of 4 is 2 square root of 5. So we're going to write our x-intercepts as -4, and then a plus or minus, and then right here I'm going to rename this 2 roots of 5. And then both of those are divided by the denominator, which is -2. So x is equal to -4 over -2 is 2. Right here, the 2's cancel. That negative actually just switches this to negative over positive, which is the same thing. So I'm not even going to bother changing it. Of roots of 5. Once again, those 2's cancel, and that's why we're left with this. So our x-intercepts will be at 2 plus the square root of 5, which would be, let's see, here's 2. The square root of 5 is a little bit bigger than 2, so it'd be kind of over here. There's 2 plus roots of 5. And then our other one would be at 2 minus roots of 5. So now we're at 2, take away a little more than 2, so that would put you right here. We can see that the number that's halfway between these values is 2. So our parabola is going to look something like this. We can tell that it's not going to have a minimum. It's only going to have a maximum. And for that maximum, we know the x value is going to be 2. Once again, just like we've done on all the other problems, if you want to find that y value, you're going to say h of the x value we saw right here is 1 plus 4 times that number minus that number squared, which would give us, was that 1 plus 8 minus 4, which is 5. Okay, so this point right here is 2 comma 5. That's our maximum. The domain is all real numbers. The range is anything that is below this y value. So the range would be from -infinity to 5. That brings us to the last example. On the last example, 4x squared minus 4x plus 1. One more time, I'm going to plug that 0 in, and I'm going to get y equals 1. So we know that our function goes through this point right here. For the x-intercepts, let's do a equals 4 b equals -4, c equals 1. So the discriminant is b squared minus 4ac, which would be -4 squared minus 4 times 4 times 1, which is, oh, you guessed it, the one case we haven't looked at yet, 0. Okay. So what happens when the discriminant comes out to be 0? Well, when the discriminant is 0, that means that the vertex is on the x-axis, which means we're only going to get one x-intercept. Let's go figure out what that is. So I'm going to cross off one of these because we know we're only getting one. According to the quadratic formula, the negative of b would be the opposite of -4, so +4, plus or minus the square root of the discriminant, which goes right here, all divided by 2 times the a value, which is 4. Okay, I get it. I see why we're only getting one answer. The thing that comes after the plus or minus is just a 0. So I'm going to kind of write this out the long way. This would be 4 plus or minus 0, all divided by the denominator is 2 times 4 is 8. But of course, 0 divided by 8 is just 0. That term goes away. And all we're left with is x is equal to 1/2. So your x-intercept is going to be at 1/2, comma, 0, which would put it, see, there's 1. So that would put it right here. Also, we know that this point has to be the vertex of the function. So we know this thing does not have a maximum. We know that the minimum is right there at 0. We know that the domain is -infinity to infinity, and the range is going to be anything 0 or bigger. So we would write that as hard bracket 0 to infinity.